Assalamu alaikum. With you, Mr. Ahmad Ali, in Rima International Schools. Today, we make explanation to chapter 20, lesson 1, part 2. What is the Earth's places in the universe? You now a model of the solar system. If we want to make a model to solar system, this is very difficult. Drawing the planets in the solar system couldn't show the actual distance between the planets. Why? Because the solar system is too huge. A regular sheet of drawing paper is not big enough to show this distance accurately. This is planets in the solar system, and the distance is not true. This is imagination only to the position of a planet in solar system. Now we can listen to this video to show what we explained.
Welcome to Moo Math and Science. In this video, let's take a look at the terrestrial planets, which include Mercury, Venus, Earth, and Mars, and then the gas giants, also called the Jovian planets, which include Jupiter, Saturn, the funny-sounding planet Uranus or Uranus, and Neptune. So let's get started. The terrestrial planets include the four inner planets, Mercury, Venus, Earth, and Mars. They are called terrestrial planets because they are rocky and solid. In other words, they are Earth-like. These planets are composed of a core composed mostly of iron and a silicate mantle. Terrestrial planets can have canyons, craters, mountains, and volcanoes. The terrestrial planets are the four closest planets to the Sun. And in order from the Sun, they are Mercury, Venus, then Earth, and then Mars. Mercury is 0.4 AU units from the Sun, followed by Venus at 0.7 AU, Earth at 1, and Mars at 1.5 AU. An AU, which is called an astronomical unit, is equal to almost 93 million miles or 150 million kilometers. If you had a scale drawing of the planets on a football field, then Mercury would be at the 1.6 yard line, Venus would be at the 2.4, Earth on the 4 yard line, Mars at the 6, and then Jupiter is found all the way at the 21 yard line, Saturn at the 38 yard line, Uranus at 76 yard line, and Neptune would be almost 120 yards away. In between Mars and Jupiter, you would find an asteroid belt. Mercury is the smallest terrestrial planet, and Earth is the largest. However, Venus and Earth are very similar in size. So let's talk about moons. Mercury or Venus do not have any moons. Planet Earth has one, and Mars has 2 moons. None of the terrestrial planets have rings. Venus, Earth, and Mars have atmospheres, and Mercury essentially does not have any atmosphere. Mars has a thin atmosphere made up mostly of carbon dioxide, argon, and nitrogen, and maybe a tiny bit of oxygen. Venus has a very thick atmosphere composed mainly of carbon dioxide, which causes it to trap in heat, and this results in Venus being the hottest planet of all the planets. The atmosphere of Earth allows us to breathe easy. It only takes Mercury 88 days to revolve around the Sun, and Mars takes 687 days to go around the Sun. Venus rotates the slowest on its axis of all the terrestrial planets and actually spins in the opposite direction of all the other inner planets. It takes both the Earth and Mars about 24 hours to rotate on its axis. Take a look at the 4 planets called the gas giants, or the Jovian planets. The gas giants include Jupiter, Saturn, Uranus, some people call it Uranus, and Neptune. These planets are massive. Jupiter is the largest of all the planets and makes our planet Earth look very small. Even Neptune, which is the smallest of the gas giants, is much larger than the Earth. Take a look at the Earth compared to the gas giants. The gas giants also take a long time to revolve around the Sun. It takes Jupiter 4,331 days to revolve once around the Sun, Saturn 10,747 days, Uranus 30,589 days, and Neptune a staggering 59,800 days. Each of the Jovian planets have a ring system. Some are faint, and Saturn is most famous for its beautiful rings that surround it. The gas giants also have a very low density. Jupiter has a density of only 1.3 grams per centimeter cubed, and Saturn has a density of 0.7 grams per centimeter cubed, compared to the Earth's density, which is around 5 or 5.5 grams per centimeter cubed. This means that Saturn would actually float, and the other gas giants would just barely sink. Another strange feature about these planets is that they don't really have a true surface. They are composed of gases like hydrogen and helium and some methane. The planets are mostly swirling gases and then liquids deeper down. The gas giants also have many moons. Jupiter has 79 moons, Saturn 62, Uranus 27, and Neptune has 14 moons. If you'd like to know more about these gas giants, this playlist will help. And as always, thanks for watching.
After we watching this video and listen as the information inside it, we complete our lesson. Why planets differ? Some planets have a very cold temperature. Others are extremely hot. Why? Because planets that are closer to the sun receive more sunlight than planets further away from the sun. For example, Venus is warmer than Earth. Large planets have more powerful gravity. Stronger gravity holds more gases close the planet. This creates a thicker atmosphere that holds in heat. Venus has thicker atmosphere than Mars. Cloud cover can also cause temperature differences. This is the atmosphere, the kind of gas inside in its atmosphere makes a process like a greenhouse, and this is keeps the heat inside the atmosphere between the Earth's surface, the planet surface, and the atmosphere. Venus and Earth are about to the same size, but the temperature in Venus are much higher than those in Earth because the thicker clouds cover Venus. Now we can watch another video to show important information.
Things we don't know, putting science in your hands.
Why are the planets so different?
If you were to take the 8 planets in our solar system and look at them as a whole, there would be 2 obvious groupings. The first of these are the giant planets, which are well deserving of their names, hundreds of times larger than the others and with thousands of times more mass.
The spectacular contrast between the 4 giants, Jupiter, Saturn, Uranus, and Neptune, and the other planets is fairly easy to explain. Before the planets were formed, all the material which they now contain was spread out in a giant protoplanetary disk.
The 4 gas giants formed outside the snow line of our early solar system. where it was cold enough to allow the relatively abundant volatile substances like water or ammonia to condense out. This gave the first baby planets in this region of the disk plenty of liquid and solid material to sweep up to form bigger and bigger planets in a process we call accretion. This process is a runaway one. Gaining more mass means more gravity means gaining more mass, and hence we get the giant planets, huge balls of gaseous material that, we think, contain some kind of rocky or metallic core at their center.
Some questions remain about their formation, particularly about their potential travels through the disk early in their lives. So that's not what we're here to look at right now. Instead, let's look at the planets we swept aside earlier, otherwise known as the terrestrial planets: Mercury, Venus, Earth, and Mars.
These planets share many similarities, but have many striking differences as well. The terrestrial planets are all formed of essentially the same stuff: silicate minerals and heavy iron cores, elements that could exist as solids and liquids in the warm inner early solar system. So in essence, they are all made of rock. Their exact composition varies slightly, perhaps due to the distribution of different materials in the early solar disk, but we can consider them essentially the same.
Venus, Earth, and Mars also have similar proportions of volatile elements, and these are materials that become gas at comparably low temperatures, like water. These substances the giant planets have plenty of, but the terrestrial planets must have collected them later in their lives. Exactly where these elements came from is a big question in planetary science. It may be that comets hit the planets, bringing these elements along with them. These three planets have roughly the same proportions of things like water and carbon, although they're contained within different types of reservoir. In some cases, the atmospheres, in others, the rocks. And here's where we see the first striking difference.
Mercury, the closest planet to the Sun, is too small and far, far too hot to retain a substantial atmosphere, and the incessant solar radiation it receives has stripped away any atmosphere that it may once have had. This lack of atmosphere means that Mercury undergoes massive temperature variations between its dark and sunward-facing sides.
Why the terrestrial planets are the size they are is something of a mystery. It may simply be chance that the particular planetesimals that formed them were larger or smaller, or it may have been due to the specific distribution of material in the solar nebula. But Mercury is the smallest, and combined with being so close to the Sun, this means it has next to no atmosphere.
Mars is the next largest and has a thin but definitely present atmosphere, mainly composed of carbon dioxide. Venus and the Earth are almost identical in size, and in fact are nearly twins in many more ways. But the two most similar planets look incredibly different to a casual observer. Venus, shrouded in clouds and acid haze, is the hottest place in the solar system, with an atmosphere so thick it could crush you many times over. Compared to Earth, Venus is a hellish world, while Mars is cold and dead. But under slightly different circumstances, these three planets might have been much more similar.
Since Venus and Earth are almost exactly the same size, it can't have been the strength of their gravity that caused the difference. Instead, as Venus is slightly closer to the Sun, it was probably just a little bit hotter than Earth in its youth. And if it didn't have such a thick atmosphere, it would probably still only be that little bit hotter. Yet the dense, sulfurous carbon dioxide atmosphere causes an intense greenhouse effect, heating the whole planet up to several hundred degrees. The thick atmosphere traps this heat and distributes it all around the planet, creating...
An important question, then, is where Venus got this tremendously thick atmosphere from. In fact, it may have been that the small difference in temperature from being slightly closer to the Sun is enough to have a massively disproportionate effect. The carbonate-silicate cycle, which governs the conversion between these two types of rock, is strongly dependent on temperature. Higher temperatures tends to mean that more silicate minerals are formed, along with the release of carbon dioxide. This carbon dioxide is a strong greenhouse gas, meaning that its release will increase the temperature a little bit more, initiating a vicious circle that has left Venus such an unappealing place to travel to. If Venus had any oceans early in its history, their evaporation would have compounded this effect, as water vapor is also an incredibly strong greenhouse gas.
The Earth, slightly further away from the Sun, and therefore slightly cooler, has undergone the opposite. Most of the carbon on our planet is locked away in carbonate rocks, leaving our atmosphere relatively clear of it, although this wouldn't have been true for certain periods of our planet's past. In fact, we actually need a little bit of greenhouse warming to make our planet anything other than a frigid, ice-covered world.
Mars is at the other end of the scale. Further away from the Sun and slightly smaller, which meant it will have cooled down quicker, it is now a cold, dead world. Its thin carbon dioxide atmosphere offers little to no warming effect, since most of it has been lost to the ravaging effects of the solar wind.
Our Earth sits in a potentially precarious place. Could the input of carbon dioxide and other greenhouse gases into our atmosphere turn us one day into another Venus? Or will our planet suffer the same fate as Mars and end up cold and dead?
Now we return our lesson. After you are listening, watching and listening the video, we complete. The temperature is mostly Mars carbon dioxide. This is gas absorbs the heat and reflects the heat back to the planet's surface. Thank you and see you again in another lesson. If you have any questions, send to me to WhatsApp or connect us another time. Thank you. Goodbye.